Richard Dawkins, The Selfish Genes. Chapter 6. Genesmanship. What's the selfish gene? It's not just one single physical bit of DNA. Just as in the primeval soup, it's all replicas of a particular bit of DNA, distributed throughout the world. If we allow ourselves the license of talking about genes as if they had conscious aims, always reassuring ourselves that we could translate our sloppy language back into respectable terms if we wanted, we can ask the question, what's a single selfish gene trying to do? Is it trying to get more numerous in the gene pool? Basically, it does this by helping to program the bodies in which it finds itself to survive and to reproduce. But now we are emphasizing that it is a distributed agency existing in many different individuals at once. The key point of this chapter is that a gene might be able to assist replicas of itself that are sitting in other bodies. If so, this would appear as individual altruism, but it would be brought about by gene selfishness. Consider the gene for being an albino in man. In fact, several genes exist that can give rise to albinism, but I am talking about just one of them. It's recessive. That is, it has to be present in double dose in order for the person to be an albino. This is true of about 1 in 20,000 of us, but it's also present a single dose in about 1 in 70 of us, and these individuals are not albinos. Since it's distributed in many individuals, a gene such as albino gene could, in theory, assist its own survival in the gene pool by programming its bodies to behave altruistically toward other albino bodies, since these are known to contain the same gene. The albino gene should be quite happy if some of the bodies that it inhabits die, provided that in doing so, they help other bodies containing the same gene to survive. If the albino gene could make one of its bodies save the lives of 10 albino bodies, then even the deaths of the altruists is amply compensated by the increased numbers of albino genes in the gene pool. Should we then expect albinos to be especially nice to each other? Actually, the answer is probably no. In order to see why not, we must temporarily albino our metaphor of the gene as a conscious agent, because in this context, it becomes positively misleading. We must translate back into respectable, if more long-winded terms. Albino genes do not really want to survive or to help other albino genes. But if the albino gene just happen to cause its body to behave altruistically toward other albinos, then automatically, willy-nilly, it would tend to become more numerous in the gene pool as a result. But in order for this to happen, the gene would have to have two independent effects on bodies. Not only must it confer its usual effect of a very pale complexion, it must also confer a tendency to be selectively altruistic toward individuals with a very pale complexion. Such a double effect gene could, if it existed, be very successful in the population. Now, It's true that gene do have multiple effects. As I emphasized in chapter 3, it's theoretically possible that a gene could arise when conferred on externally visual label, say pale skin, or a green beard, or anything conspicuous, and also a tendency to be especially nice to bearers of that conspicuous label. It's possible, but not particularly likely. Green bareness is just as likely to be linked to tendency to develop ingrowing toenails or any other trait. And the fondness of green beard is just as likely to go together with the inability to smell fresias. It's not very probable that one and the same gene would produce both the right label and the right sort of altruism. Nevertheless, what may be called the green beard altruism effect is a theoretical possibility. The arbitrary label, like the green beard, is just one way in which a gene might recognize copies of itself in other individuals. Are there any other ways? A particularly direct possible way is the following. The possessor of an altruistic gene might be recognized simply by the fact that he does altruistic act. A gene could prosper in the gene pool if it says the equivalent of body. If A is drowning as a result of trying to save someone else from drowning, jump in and rescue A. The reason such a gene could do well is that there is a greater than average chance that A contains the self-life-saving altruistic genes. The fact that A is seen to be trying to rescue somebody else in a label equivalent to a green beard is less obviously than a green beard, but it still seems rather implausible. Are there any plausible way in which genes might recognize their copies in other individuals? The answer is yes. It's easy to show that close relatives, kin, have a greater than average chance of sharing genes. It has long been clear that this must be why altruism by parents toward their young is so common. What R.L. Fisher, J.B.S. Haldane, and especially W.D. Hamilton realized was that the same applies to other close relations, brother and sister, nephew and niece, close cousin. If an individual dies in order to save 10 close relatives, one copy of a kin altruism gene may be lost, but a larger number of copies of the same gene is saved. A large number of it vague, so it's close relatives. We can do better than that. Hamilton saw his two papers of 1964 among the most important contributions to social ethology ever written. And I have never been able to understand why they have been so neglected by ethologists. His name does not even appear in the index of two major textbooks of ethology, both published in 1970. Fortunately, there are recent signs of revival of interest in his ideas. Hamilton's papers are rather mathematical, but it's easy to grasp the basic principle intuitively without rigorous mathematics, though at the cost of some of simplification. The thing you want to calculate is the probability or odds that two individuals, say two sisters, share a particular genes. For simplicity, I shall assume that you are talking about genes that layer in the gene pool as a whole. Most people share in the gene for not being an albino, whether they are relate to each other or not. The reason this gene is so common is that natural albinos are less likely to survive than non-albinos because, for example, the sun dazzles them and makes them relatively unlikely to see an approaching predator. You are not concerned. It explains the prevalence in the gene pool of such obviously good genes as the gene for not being an albino. You are interested in explaining the success of genes specifically as a result of their altruism. You can therefore assume that, at least in the early stage of this process of evolution, these genes are rare. Now the important point is that even a gene that is rare in the population as a whole is common within a family. I contain a number of genes that are rare in the population as a whole, and you also contain genes that are rare in the population as a whole. The chance that we both contain the same rare gene is very small indeed, but the chances are good that my sister contains a particular rare gene that I contain, and the chances are equally good that your sister contains a rare gene in common with you. The odds are in this case exactly 50%, and it's easy to explain why. Suppose you contain one copy of gene G, you must have received it either from your father or from your mother. For convenience, you can neglect various infrequent possibilities. That G is a new mutation that both your parents had it, or that either of your parents had two copies of it. Suppose it was your father who gave you the gene. Then every one of his ordinary body's cells contained one copy of G. Now you will remember that when a man makes a sperm, he doles out his help, his genes to it. There's therefore a 50% chance that the sperm that begot your sister received the gene G. If, on the other hand, you receive G from your mother exactly parallel, reasoning shows that half of her eggs must have contained G. Once again, the chances are 50% that your sister contains G. That means that if you had 100 brothers and sisters, approximately 50 of them would contain any particular rare gene that you contain. It also means that if you have 100 rare genes, approximately 50 of them are in the body of any one of your brothers or sisters.